Okay, so we got the recording going. I'd say it's time to do this dance, huh? All right, let's see. Easiest stuff I can do right now. I'm just going to plug in my phone. I'm dialed in, so I want to make sure I don't lose you guys while I'm in the middle of teaching. So I'm just going to plug in my phone to a charger. Okay. All right, guys, it's about to get scary. All right, let's do this. All right, I'm going to risk it. Yeah, I feel like I'm scared now. See if we're still driving. Okay, so we're connected here. Looks like we're connected here. And let's make sure the VPN is still set up. Okay, looks like I'm hot on the VPN. Let's make sure the page is working. Page looks like it's working. Let's dance. Okay, guys. Man, oh man, oh man. Man, you guys only knew the week I was having. And you would just giggle. I did a double shot rum and coke about an hour ago. My week has been that crazy. Okay, let's get going, guys. So what we're going to be doing is we're just going to be covering some basics of web app right now. I think the easiest thing to do, basic ASP.NET. I used to teach a lot of classic ASP, and this year I decided to drop the classic ASP and pretty much just move straight on to ASP.NET. Not that there's significantly anything different. The only real difference is classic ASP is usually much more vulnerable. So you really don't run into too many cases where they're hiring you to test a lot of classic ASP anymore. And then if you do, pretty much any vulnerability scanner will handle it. It's not too much manual stuff that you really have to do with a lot of classic ASP these days. Okay. All right, so let's just get started. The host I'm going to start with is 10.10.10.105. Let me get my Zoom it going so I can zoom in on some stuff for you guys. So you'll see here's where I'm at, 10.10.10.105. And as you browse to the page, you're going to see that it's just a normal website. If I mouse over stuff, you'll see in the bottom corner, that items show up, right? So I moused over login, and there's this JavaScript do postback function. It's what's being passed to it is CTL $00 $LB login. I'll mouse over this. And you see that this one's doing the same thing, except what's being passed to it is LB contact. Okay, so we've definitely got a little bit of JavaScript action happening here. Not too bad. We've got a search box, so when I type stuff in the search box, I just type hello, see what it does. Okay, so we see that basic search.asp, parameter passing, parameter name is word, parameter value is hello. So when we see it be passed to the web server, it gets passed as a GET request. Now, anything that's up here in the address bar, we're going to call that a GET request. When you have stuff happening and the address bar doesn't change, usually on like form submissions, logins, any critical transaction, those are generally going to be called post requests. So if nothing is changing up here at all, nothing's changing up here, it's probably a post request. If you see stuff happening up here in the address bar, that's generally a GET request. So as we look at this, we see that it's like, not too bad. If I move over one of the links down here, you see that it's book detail.aspx, question mark for parameter passing, ID is the parameter name, and 1 is the parameter value. So it's passing the value 1 with the parameter name of ID to the database. Okay, pretty interesting. All right, and as you kind of look around the rest of the site, there's not that much more to it, right? There's a subscription form, a little bit of data on the far side. The rest of the stuff is all bookdetail.aspx. You guys notice that? Every link is bookdetail.aspx, question mark ID, and every link is a different parameter number, parameter value rather. Okay? Well, it's pretty easy. I'm going to click on the contact page. So I click on the contact page, and that's awesome. Throws an error. Not supposed to do that. See? Let's try another page. All right. Throws a login page. Now, the login page doesn't have any parameter passing, so most likely it's going to be a post request. So if I insert just, anything here, right? Hello, hello, hello. When I submit this, you notice how nothing changed in the address bar? There was no parameter passing in the address bar. The request went, but there was no parameter passing. So I'm just going to hit Tools, Tamper Data, start my tamper. I'm going to do the same thing again. Let's do a hello. I'll hit go. And now you see, if I want to tamper with it, let's take a look at it. And I was right. It is a post request. See that? Now, with a post request, you can mess with it using a proxy. This is why you hear people talk about WebScare, Burp Suite, Rat Proxy, Peros, Zap, and all these, Fiddler, and all this kind of stuff, because it allows you, when you have a post request, to interact with that traffic between the browser and the web server. So you can do stuff here. So I'll give an example. If you wanted to change the refer right here, so let's say we're looking at the refer. This tells you the page, this tells the web server the page that you came from. If you had to make a purchase, if the application required you to make a purchase, a lot of times the application will check the refer to verify that you came from the payment page before allowing you to download a piece of software or ebook or something like that. So what you do is you manually go through the entire website and map out the data flow through the website. Once you figure that out, you see, okay, after I purchase this, it redirects me to the download page. The download page, as long as it came from a refer of whatever, that's what's being checked. Now when you try and see if I browse to it directly, change my refer to say that I came from the purchase page. Let's see if it lets me download something. Okay. Other things that you can do, a lot of people don't think of. So let's say, for example, here's your user agent. So here's your user agent. In my case right now, I'm on the road, so sometimes it doesn't work anymore. But Boingo Wireless had a deal where if you had an iPhone, you got free internet at airports. So what you do is it figured out that you had an iPhone by checking the user agent. So if the user agent was that of an iPhone, you'd go into your proxy or Firefox and just change the user agent. This is why you see a lot of people who like things like user agent switcher, Firefox add-ons that do that kind of thing. Okay. Another thing that a lot of people don't realize that you can do is, let's say, for example, you have these post parameters, right? So I've got the search page, right? And what you can end up doing is in these items here, you can, let's try and do this over here so you can see it a little better. You can actually insert cross-site scripting and SQL injection in these places here. So you right-click on any of the fields, and then you can choose cross-site scripting, SQL injection, and then you can start building out your statements. Okay, so here's the parameters, right? So you go tick or one in, select user dash dash, right? This is where you put that, right? Or maybe you do, like this, or 1 equals 1 dash dash. Right? So here's the login, and now we could try this way. Right? And then we submit it, and we try to see if it logs us into the site. Okay? All right. Well, that didn't work, but it sure was a good try. Okay. Now this is really, really interesting. If you notice, we didn't get an SQL error. Right? We were testing for SQL injection, but we didn't get an SQL error. What we got, something else. Can anybody tell me what this is? What's going on here? Why is this a big deal? Definitely hard-coded usernames. We'll get to that. But this part right here, what are we dealing with? Okay, there you go. Yeah, definitely XML. There you go, XPath. So what you have is not SQL injection. What you have is XPath injection. Now, with all of these things, when you start dealing with this kind of stuff, a lot of people, they get real bent out of shape about, testing for XML injection versus testing for LDAP injection versus testing for SQL injection, and I even heard of MX injection. Like really, at the end of the day, all that matters is whenever you see parameter passing, you want to insert a tick. Right? Whenever you see parameter passing, insert a tick. And then when you submit the request, see what it does. When you see what it does, if it throws an LDAP error, then you're dealing with LDAP injection. If it throws an XPath error, then you're dealing with XPath injection. If it throws an SQL error, then you're dealing with SQL injection. So you don't need to beat yourself up over, well, man, I don't really know how to test for, XML injection. I don't really know how to test for XPath or query. I don't really know how to deal with XML RPC. You get people who get afraid of these technologies. But at the end of the day, the website is communicating with the data store. The data store can be a file. The data store can be a database. The data store can be a web service. The data store can be anything, right? So as long as the web server is communicating with it, that's parameter passing, that's when you send a single quote. So like right here, right? If you look here, when I mouse over this link, it's book detail.asps, question mark ID equals 1, that's parameter passing. ID is the parameter name. 1 is the parameter value. So we see that there's parameter passing. Let's click on that link. Let's see where it takes us. So I clicked on that link. Here is question mark, lets me know there's parameter passing. ID is the parameter name. 1 is the parameter value. I'm going to insert my single quote. I insert a single quote. I press enter, and now boom. Okay. But now here, let's look at the error. You guys see the error? Okay, so this is not XPath XQuery. What are we dealing with here, guys? SQL injection. Perfect. Good job. Exactly, guys. Exactly. So you're seeing that this is not that bad. It's not that bad. You browse the website and you ask yourself 3 questions. Question number 1 is you talking to a data store. So if you see parameter passing anywhere, that's where you test for injection vulnerabilities. And the way you test for an injection vulnerability is to insert either a single or a double quote after, immediately after, like this, immediately after, or in place of the parameter value, like that. Okay? So now it can be in a GET request or in a POST request. If it's on a POST request, you're probably going to want something that can trap the request. So I'll send my hello right here. I'll send my hello right here. Now, I'm going to start my tamper. When I say go, let's tamper with it. Let's take a look. Right here will be where you, because these are the parameters, right? Those parameter values, you see right here. So here would be where you would throw your single quote. Or you replace the entire parameter value with a single quote. Okay, just like that. Okay, not hard at all. Now you realize that you just browse every single page of the website, and that's what you do. I mean, it's really that simple. So all you have to do is learn to read the errors and the behavior. We'll get to the behavior a little later, okay, because sometimes it doesn't throw an error, and you got to kind of understand the behavior to figure out what the back-end data store communication language is. You know, is it SQL, is it XML, you know. We'll learn that later. But right now, whenever you see something, web server communicating with the data store, insert a single quote. It's that simple. It's that simple. You browse every single page of the website, and that's all you do. I mean, that's really it. Okay. Now, let's throw some death by PowerPoint. Okay, so if we think about programming, and we think about why we all hated programming in college, maybe you didn't, I did, I sucked at it, maybe that's why I hated it, but let's move on. So let's say you have an integer. So you see here that I've got int equals 51550. And you see that I've got string, and that's Joe, and string 2, that's Joe McRae. But you guys notice that I have, excuse me, you guys notice that I have a single quote at the beginning and the end of the string. This is important because computers are great with numbers, but they're horrible with words. So they need something that lets them know when is the beginning and the end of a string. Now, if you look at this slide, we've all done this before, right? What's going on? Can anybody tell me what I've done wrong? Look at the screen. What have I done wrong? And there you go, unbalanced quotes, right? So in some cases, I've got a single quote on one side, double quote on the other side. Quotes need to be balanced, right? Not doing that will cause it to throw an error. They'll usually throw an error that looks something like this, right? Unclosed quotation mark after the character string. Now, there we go. Unclosed quotation mark after the character string. Now, what's going on? Let's say we have something like this. You see the select statement? So we've got a string query, select all records. Oh, excuse me, I don't know what's going on with me yawning. Select all records from products where product ID equals request ID. Oh, you can't see what I'm doing? Let me check my screen. Okay, you should be able to see my screen. Let's see. View. Okay. Okay. Should be just a screen that says the basics, what's actually happening. Yeah, okay, no problem. Okay. Okay, so if you look here, you see where it says select, and the asterisk is just all records from products where product ID equals, and you've got request, and then in brackets, ID table called products, and there's probably a column called product ID. And then the request part lets us know that it's coming from the web. So as you look at that, you're like, okay, look in the very next line below, where it says, in this case, ID is actually coming from a web request. So you see it's site.com/products.asp question mark ID. God, I can't stop yawning. Sorry about that, guys. Please stay awake. Okay, ID equals 51550. Now let's take a look at this next slide. Now what if someone were to put a single quote after the 51550? What you'd end up with is the string query, select all records from products where product ID equals request. And then you see in the numbers, you got 2 quotes on one side, 3 quotes on the other side. And this is going to be the same thing as this. So you see this if 51550 with a single quote, it's the same thing. You know, truthfully, this is the root cause of what we're doing. When we're trying to test for SQL injection, this is what you're trying to do on the back end, right? This is what you're trying to do to that developer's SQL query. So now when someone's actually doing an attack where they're trying to insert SQL statements, the syntax looks funny, right? You'll see something like this. ASP question mark question mark ID equals 51550. Then you've got or 1 in select user. Now when you look at the query, you know, the base of the query is the same, but the where clause looks weird. Request equals 51550 or 1 in select user dash dash. So, you know, WTF, right? Okay, so let's figure out what that is. Why the or 1 in? Why the or 1 in? Let's say you've got 5 equals 3 plus 2. Now, if you say, all right, I got 5 equals 3 plus 2, it's basically the same as 5 equals 1 plus, and in parentheses, 2 plus 2. But my question to you is, what do the parentheses signify? What's the importance of the parentheses? Anybody? There you go. Order of operations, good. The parentheses let you know what you need to do first. So the 2 plus 2 is what needs to be done first. So here, what's in the parentheses is the select user statement. The select user statement is going to be executed first. Right, good job, Hitachi. Yeah, you're right. The select user statement is what's going to be executed first. Now, the result of the select user statement is DBO. So select user, DBO, database owner, right? Now let's look at the rest of it. In is another way of basically saying equals. Not literally, but for our purposes, let's just call it that. Okay, so what you've really done is you said 51550 or 1 equals DBO. And in programming, can anybody tell me what's the difference between a single equal sign and a double equal sign? Talk to me, guys. What's the difference? Okay. Okay, operation versus operator. Okay, Matt says that it's an absolute. Okay. All right. Now, a single equals is an assignment. This is this. A double equals is a test. Does this equal this? So really what you're doing is you're saying 51550 or 1 equals DBO. So 1 is DBO. It's an assignment. Now 51550 is an integer. DBO is a string. So assigning an integer to be a string or vice versa, usually with computers, not so good. Generally you have to, perform some sort of conversion, perform some sort of task operation, something, right? You can't just say a string is an integer. Computers don't like that. They're not cool with that. So we're doing that on purpose. Because if you look at what's going on here, assigning the integer to be a string will throw an error. And what you're going to get is this conversion failed when converting the n-varchar value of DBO. See that? That's the result of the select user statement into data type int. So forcing the application to throw an error, we can see the result of the SQL query. This is called error-based SQL injection. So let's say we take a look at the website. It's right here. Let's go back to the home page. So right here, I've got bookdetail.aspx, question mark, ID equals 1. I'm going to throw my or1 in select user all right here. I'll put all that stuff right here. Okay? Now because the parameter value is an integer and not a string, I don't need my single quote. That's a good little tip to know. If the parameter value is a string, you need to keep your single quote there along with your SQL injection syntax. So we're just going to say or1 in select user like this, dash, dash. And then you see that. Conversion failed when converting the n-varchar value of DBO into data type int. So DBO is the result of the select user statement. Now, a common question I usually get right here, why the dash dash? Okay, can anybody tell me why? Why do we have that there? Okay, it's a comment, but why? Why do we need it? Okay, Zach, you're right. Pete, you're right. Why? Okay. All right, yes, we want to end the statement, but remember, you've got the developer's code. Right here, you've got the developer's code. Request equals, and then you've got 51550. Now, what if after the request, there was more SQL statements after that? Your comment would comment all of that out, right? Because what you don't want is you don't want the developer's code that comes after the where clause to cause your statement any errors. Yeah, exactly. So the syntax after your inserted SQL statement doesn't break the query or vice versa. His remainder of his query break yours, right? So it's easier to just comment it all out. Now, a good tip to remember here is a lot of times web application firewalls, that's what they're looking for. They're looking for comments. So a lot of times with a web application firewall, you can have a select, a union, group by, order by. You can have that kind of text in the GET request or the POST request, but if it's immediately followed by comment, it's often flagged as SQL injection when not having it isn't. Okay, so we've got a question. Why is 51550? It means absolutely nothing. We can have a number 1 right there or a 10 right there. It's purely for an example. So it's just to give you an idea what the syntax looks like. It means absolutely nothing to our lab right now. Okay. All right. Okay. Now, for those of you who are connected to the VPN and trying some of this stuff with me, I'd like you to kind of try a couple of things. So we're going to select user. Let's change this and let's go DB_name. And then put a 0 in there. Okay, so I'm going to paste this in here, like this. Oh, there you go. Yeah, guys, so the search has a good example of using the comments to try and avoid errors, right? Good job. Okay, guys, so I just pasted in a link, and you guys try it, and I just did dbname 0, right? So I did dbname 0. So that's the first database. The first database is called book app. Now, if you change that 0 to a 1, what do you get? Anybody tell me? Change that 0 to a 1. For those of you who are connected to the VPN, try it. Okay, tell me what's the name. What do you get when you change the 0 to a 1? Anybody? Come on, you guys can get this. Master, good. Okay, so I'm going to do the same thing. I'm going to change it to a 1. Okay, and I get master. Change it to a 2, guys. Come on. Tell me what's the next database. Good. TempDB, good. I'm going to change that to a 2, and you see that I get TempDB. Change it to a 3, guys. What's the next database? Come on, guys. What's the next database? Change it to a 3. And boom, model. Good. Okay, guys. Now, if I ask Google, I go master, model, TempDB. It says MSDB. These are what, guys? What are they, guys? Anybody? Good. Not tables. Not tables. There you go. There you go. These are the default databases These are the default databases, right? Now, if we keep picking up the number, right? So 4, I get MSDB, 5, boom. Now I start coming up with additional databases that have been added. Make sense? So now you just keep going through. This is how you get a listing of all the databases on the server. Okay? So here's how you do that. So this is database enumeration. Now, when you're doing SQL injection against a closed source application, you have to do this process, right? You have to map all the databases. Then you map all the table names. Then you map all the column names. Then after that, you can start writing queries to extract data from them. Now, when it's an open source database, it's generally a one-liner. You just steal the first username and password and log into the app. So on the defensive side, when you're dealing with a closed source database and there's SQL injection, you're going to have a lot of data in the logs because the attacker is going to need to map the schema, map all the system databases, third-party database. You're going to have to map all that stuff. So in your logs, you're going to see all of that. Okay. Now, if it's an open source database like WordPress, Mambo, Drupal, Joomla, any of that kind of stuff, where Bulletin, PHPBD, anything that's open source, you're going to see a one-liner. So those are actually harder to find in the logs because it's only one line and the guy has immediately got the admin credentials for the database or any key piece of data that he wants because the schema of the database is public. Now, our next question is, how do I know what kind of database it's running, be it MySQL, MSSQL, Oracle, etc. So let me just throw in 107. Hope she's online. Okay. Now, when we put in our tick, so here's our tick. Here's our tick. Usually from the error message, you'll be able to determine what type of database it is. So we've got a couple of tips. The first tip is the web app language. ASP, ASPX usually talk to Microsoft, MSSQL, whereas PHP usually talks to MySQL. That's not always the case, but usually. Now, when you insert your tick and you get your error, the error message will usually tell you what type of database it is. See that? So you usually get an Oracle database error, a MySQL database error, a Postgres database error. You'll get a MSSQL database error. And as you look up the actual error message, you'll start to see, yeah, that's what this is. Now, as soon as you do that, you immediately go, what's the user, right, which is what we did. Okay, what's the user? And then after that, you can usually say app version. And then he should give you all the goodies. See, he's SQL Server 2005, and he's on Windows NT 5.2 Service Pack 2, so that's Server 2003 Service Pack 2. Okay. Now, you're going to have to do that a little bit different. The syntax is similar, but the way that you go about it, the injection vector is a little bit different. Next week, we're going to cover PHP. Okay. Okay. All right, how you guys doing so far? Everybody following along okay? Nobody lost? Okay, sweet, sweet. Yeah, big thing, guys. I'm trying not to fly through it. I don't want anybody like, oh my God, you know, what is he talking about? I'm trying to keep it at a pretty fair pace. Okay, so now that you've done that, you know, browsing the website isn't that bad. It's not that bad. You're going to notice that I teach the entire class of auditing the website by hand. We're really not tool monkeys in this class, because once you come up with your process, you test every page for parameter passing, whether it's a GET or POST request, and then based on the error or based on the behavior, you'll know if there's an injection vulnerability. Later on, next week, I'm going to teach you test every page for abuse of trust vulnerabilities. Is there a place where you can see what you type, like this, right? So a search box, you know, like somewhere where I can see what I type, a login box, a form field, right? A guest book, a blog, anywhere that I can write, and either I can see it or someone else can see it. That's where you try process scripting. Okay? Same thing where we found the parameter passing. Wherever there's parameter passing, either in a GET or POST request, that's where we try inserting our single quote. Insert your single quote or double quote, analyze the behavior, because that's going to let you know if an injection vulnerability is present. Any single where, question 2, any single place that you can see what you type, you insert a cross-site scripting. If it reflects back, then you know command execution is possible. Sorry, JavaScript injection is possible. Then you move forward with trying to see if you can attach to the cookie, then trying to see if you can redirect the cookie. We'll cover all that next week, so you don't need to be like, oh my God, you know, what's he talking about? But you know, testing the website by hand is not that bad. I was super paranoid about it before. You know, I just thought it was going to be so hard. But the biggest thing that I can tell you is a lot of people, for some reason think that, let's see. A lot of people, for some reason, think that testing a website is so hard and testing a network is so much easier. And it took me a while to figure this out, but I want you to think about it this way. The reason that testing a network is a lot easier for a lot of people is not that networks are less complex than apps. They're not. Generally, networks are more complex than an app. When you're dealing with an app, you don't have anywhere near as many moving parts as you do in a network. But people can visualize a network. Very few people can visualize an app. So let's look over here. You see we've got client web browser. Okay, it communicates with the web server over HTTP. When you're at the web server and you're interacting with the web server is going to interact with you by giving you web server response codes. 200 means what? Can anyone tell me what a 200 response code is? That's okay, good. He might give you a 301, right? A redirect. What's a 404? Can anyone tell me what's a 404? Okay, file not found. Perfect. So if when you're interacting with the website and you're getting 301s, 302s, 404s, that's the web server. You see right here where it says presentation layer, the web server? That's the web server talking to you. If you're getting like no pointer dereference, type mismatch errors, and things like that, that's the app server talking to you. Now, if you're getting ODBC, JDBC, you know, ADODB, you're getting stuff like that, you know, that's the database, the resource layer talking to you. So, as an example, I had a VBScript type mismatch error. I spent like 3 days trying to find SQL injection. Can anyone tell me why it took me 3 days before I finally gave up? What was I doing wrong? I had a VBScript type mismatch error. I kept trying to do SQL injection. I kept saying to myself, I know it's vulnerable. I know it's vulnerable. Okay? What was I doing wrong, guys? What was I doing wrong? Where's the error coming from? DB script type mismatch, where's the error coming from? Coming from the presentation layer? Is it coming from the business logic layer? Is it coming from the resource layer? Where's it coming from? There you go. It's coming from the app layer. So me trying to insert SQL injection here, that can only happen at the database layer. So once a person can figure this out by app behavior and app error messages, that's what allows you to figure out what to do, right? So if you're getting 301s and 404s and stuff like that, you need to be trying web server stuff. Wherever you are, you're messing with a web server. If you're getting, null pointer dereference, DB script type mismatch, you're getting all these different app errors, then you need to try to figure out what language the app was written in, and you need to try to send commands to the app or syntax and strings to the app to try and make the app behave in a different way. If you're getting, ODBC, JDBC, database connection type errors, then what you need to do is you need to be trying to send, database commands. If you're getting LDAP errors, that's still resource. You need to send LDAP syntax instead of SQL syntax. Does that make sense, guys? And I know that sounds trivial. I know you're thinking like, way to go, Captain Obvious. But I'm telling you, it took me a year of doing web app testing before I finally figured this out, because I would spend so long messing with something only to realize that I was messing with the app when I thought I was messing with the database, or messing with the database when I thought I was messing with the app, but, messing with the web server, And what messes you up mentally is because all three layers can be on the same physical server, right? The web server can be on one server, the app server can be on the same physical server, and the database can be installed on the same physical server. Or they each can be on their own separate physical servers, or any mixing where, like, you might have the web server and the web app on one box, database on another, right? Yeah, Zach, perfect. Yeah, messing with an IPS too, right? So something in front of the web server out here in the request response land, messing with stuff, killing connections and, changing the error messages that come back to me, or suppressing error messages, making me think that I'm up against something else. But I'm going to try and spend as much time as I can trying to teach you about application behavior. Because when you can read what the app is doing, it'll be a lot easier for you to test by hand. And when you can test by hand, you're going to be surprised at how many things you find that the scanner doesn't find. Just straight misses it all the time. You're going to be blown away. You're going to be like, man, I can't believe that the scanner missed that SQL injection or missed that cross-site scripting. That happens all the time. Okay. Let's go back. Let's look here. Okay. All right, I'm cruising down around the site. I don't see anything at the bottom of the page. We cruise up to the top. Okay, pretty much all we got is the search box up here. I'm going to throw a generic cross-site scripting up there. Boom, looks like we've got cross-site scripting. Okay. All right, so we're going to have to talk about how cross-site scripting works. And we won't be doing that today, but we will cover it. Okay, so let's see. We've definitely got cross-site scripting here. Okay, let's see if we have cross-site scripting here. Okay, I'll go for that. Yep, looks like we got cross-site scripting there too. Okay, so in the basic search, looks like we've got cross-site scripting. Okay, so we're going to have to talk about how this works in our next time if you're only doing SQL injection today. So it looks to me like we've got a pretty healthy chunk of vulnerabilities that we can play with. Okay. All right, guys. Now, does anybody remember? Is this a GET request or a POST request? What's this up here? GET request or POST request? Beautiful. The GET request. Okay. Now, when you articulate this to the developer, you're going to say the GET request to page basic-search.aspx has a parameter name of word that is vulnerable to cross-site scripting. Does that make sense, guys? The GET request to basic-search.aspx has a parameter name of word that is vulnerable to cross-site scripting. Okay? You have to be able to tell the developer exactly what page has the issue and what parameters that are being passed to the page specifically has the issue so that you can test it and you can figure out how to write input validation around it. Okay. All right. Now, with each one of these drop-downs, I'm still going to try this cross-site scripting, but you guys notice that I'm changing this drop-down. Okay, so I'm going to search that, see if I have cross-site scripting there. Yep, I sure do. Okay, but I don't know if you guys notice, it's still the same page. Look at that. Basic search.aspx, right, is the page name and the GET request that has a parameter name of word that's vulnerable to cross-site scripting. So even though I changed that little block, the actual root problem is still the same. Now, this is important, right, because if you run a vulnerability scanner, your vulnerability scanner is going to pop up and tell you that you have, 300 cases of SQL injection, when really you probably only have like 2 or 3. You have like one page with several pages of parameter names that are vulnerable, but it's probably the same page or 1 or 2 pages. So this is a real big deal of trying to get the customer to understand that you're not here to beat them over the head with vulnerability stuff. You're just trying to help them understand, like, hey, if you do this and look here, you only need to fix it in this one place. Okay? All right, guys, does that make sense? Everybody picking up what I'm putting down? Okay, you guys still there? Did I lose you? Oh, okay. Man, I thought I lost you guys. Okay. Good, good, good. All right, guys, we hit our first hour. Let's take 10 minutes. Take ourselves a quick break, loosen up a little bit, stretch. Let's get back in here. Picking said, put down things. Yeah, Zach. Wow, dialing in with audio still puts you in listen only. Okay. What you want to do is the application will have, like, if this dial isn't working, you hit that. It'll redirect you to another page with a different phone number. What that means is the phone call line, the conference call line is down. Yeah, I've run into that a few times myself, trying to dial in to teach a class and it wouldn't let me. Okay, guys, let's take a break. Matthew says, I get to practice being a good mind. All right, guys, let's take 5. Let's take 10. You're right, guys, I'm so sorry. I'm talking, thinking you guys are listening. What I told you I wanted you to do was these three. Go ahead and do them. Just start pasting them into Firefox and start telling me what's going on when you do this. What are you seeing? You know, tell me what's going on. Yeah, thanks, Matt. You're right. I was muted. Left a surprise on the home page. Really, man? Come on. I got to teach the class. I'm going to jack up the website while I'm trying to teach. Okay. It's okay, Zach. You got to have a box to have fun on once in a while. Okay. So, guys, what's going on here? Can anybody tell me? What's going on here? Why is being able to put this in parentheses a big deal? Anybody? Why is that a big deal? Oh, it's quiet on the Western Front. Come on, guys. It's a big deal. Okay. I put ID equals 2. I get this page. I put 2 in parentheses. I get this page. I put ID equals 3. I get this page. I do in parentheses 5 minus 2. I get this page. I do in parentheses 5 minus 3. I get this page. Okay, what's going on? What's going on? This is a big deal. We've got to tell the developer about this. This is huge. Something's going on. Okay, something, whatever's inside of the parentheses is what? What's happening to it? It's being what, guys? It's being evaluated. Good. It's being calculated. Good, Hitosh. Good. Zach. Good. Yeah. There you go, Matt. Good. Good. It's being evaluated, right? It's being executed. When you can perform arithmetic functions, you're proving that command execution is possible, right? You're proving that because, I mean, at the end of the day, any command that's being executed is functionally just math, right? So if you can execute math, you're just one step below being able to execute command. So all we need to figure out is the database evaluating or is the web application evaluating? Most likely it's the database in this case, most likely. So we are proving SQL injection. This is huge. This is my go-to for when I have a web application firewall. Because a web application firewall is usually going to look for common SQL syntax. Select, union, order by, group by, having, you know, any of the common SQL operators. But he's not going to be looking for like a 5 minus 1, 6 minus 2. He's not going to be looking for stuff like that. So it's a great way for me to test for SQL injection. You've just proven that SQL injection is possible, guys. Okay? All right, let me make sure that you guys have the newest paste in. Okay, so that's the new paste in. Okay. Okay. You fixed it for me? You unhacked my page? Zach, the friendly hacker. You gotta love it, man. You gotta love it. Thank you, Zach. I really appreciate it. Okay, so let's throw something in here. And this one's pretty interesting. Can anybody tell me what's going on here? Okay, break out your Google Foo. Tell me what this query is doing, right? Now, when we were doing this 401 select DB underscore name like this, right? It was telling us that this was look at. Can anyone tell me how that differs from this? Okay. Select top one, name from sysobjects, where X type equals char 85. Break out your Google Foo. Who can tell me what all this means? What is all that gobbledygook? Okay, specific character set. There's more. Okay, I'm looking for objects with a specific character set. Okay, we're close. We're close. Okay, select the top one name to give me the first record. Okay, from sysobjects. What's sysobjects, guys? Okay. Okay, sysobjects is a table. So we say what's sysobjects? That lets us know. Okay, sysobjects contains a row for each user-defined schema-scoped object that was created within a database. Okay. Contains a row with each object. Okay. All right, so sysobjects is a table. Okay. All right, so sysobjects is a table. Okay. Now, what about X type equals, what do we have? What was it? X type equals char 85. Char 85. What is that? Anybody figure out what that is? X type equals char 85. Okay. And it's the character for the what? It's the character for what? New line. Good, good. So what you're doing is saying, hey, go to the sysobjects table and then select the top one record of the next line from the sysobjects table. Those are going to be user-defined objects. Does that make sense? So that's going to give me the first user-defined table name. So SQLMap output was a temporary table created when someone ran the SQLMap tool. So what you can do is you can say and greater than, and name greater than, in quotes, SQLMap out. Put like that, dash, dash. Uh-oh. I must have used the wrong syntax. Oh, did I need a parenthesis? I knew I jacked it up somewhere. Oh, okay, and I needed a parenthesis. Let's see. Like this. Yeah, I needed to close that parent, huh? Sweet. Let's see. Oh, two dash dashes. And then greater than. No. X type A plot and then greater than that. Go just like that. Boom. Whoa, he does not like that, huh? So the top one name where X type try and name greater than bookmaster. Let's try sys, whoops, SQLMap output. Oh, he doesn't like that either. What does he want, an additional call? Oh, let's get rid of this parenthesis here. There's our problem. Yeah, guys, that was my mistake. I left a parenthesis here. Okay. All right, so that table name was SQLMap output. What I did was I said, hey, can you give me and the name of the one greater than SQLMap output? And he says, hey, that's sysdiagrams. So now what I'm going to do is I'm just going to grab sysdiagrams like this. And I'm going to paste that right in here like that. Too easy. And boom. Okay. So looks like there's no table after sysdiagrams. So let me see. I think our first table name is bookmaster. Okay, so bookmaster, SQLMap output, and sysdiagrams. So that temporary table that was created by SQLMap hasn't been deleted. So those are our two table names. Yeah, thanks, Matt. You're right. Okay. So these syntaxes should still work. Let's grab these and try all of these. So the first one should give me, okay, SQLMap. Okay. The second one, give me the one greater than bookmaster. And give me the one greater than the diagrams. Oh, looks like I pasted two lines. And boom. Okay, so after sysdiagrams, there's no more tables, right? Those are our last tables. So this website really doesn't have a lot in it, because obviously it's an intentional and vulnerable site. So we started by getting the database names. Then we started by getting the table names. We got the table names by looking at anything greater than, any tables greater than the sysobjects table, right? Those are going to be user-created tables. And because we've had people running SQLMap against this, SQLMap output was one of the user-created tables. So the two should have been bookmaster and sysdiagrams. Okay. All right. Now we got one last trick that I want to show you guys, and it's called an order by. And I love this. So I want you guys to give this a try. So you're seeing that I'm doing order by 100. Order by 100. So when you guys look at that, key thing that we have to figure out here is it says, all right, order by position number 100 is out of range. Okay, so no, 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 no. You don't have 100 columns. So I want you to think about it this way. If you've got 10 columns, you can order by 5. You can sort by 5. But if you've got 10 columns, you can't sort or order by 50. So I'm going to say, okay, I don't have 50 columns, 100 columns. Let me try 50. I do that. Nope. Don't have 50. Let me try 25. Let me try 25. Nope. Don't have 25. Okay, let me try 12. Nope, I don't have 12. What should I try now, guys? Okay, let's go 13. Now, 13 will be going up, right? Okay, no, we don't have 13, so we probably want to cut it in half. What will be a better number to try? Okay, 11. Okay, no 11. Okay, what else should we try? Okay, 2. So I'll go in here, let's try 2. I try 2, I get a valid page. Okay, so there's more than 2 columns, but there's less than whatever our last number was. I think it was 11. Okay, so let's try 6. I try 6, I get a valid page. So what should I try? Okay, so I'll try 7. Okay, I get a valid page at 7. What should I try, guys? Okay, I'll try 8. Still get a valid page. What should I try? Okay, 9. Still get a valid page. Okay, if I throw in 10, boom. So how many columns do I have? Anybody tell me? I have 9 columns. So I'm going to try union all select 1, 2, 3, 4, 5, 6, 7, 8, 9. And I should get either a valid page or a valid record in the database. This is a valid record, A Guide to Wireless Engineering. That's a book. So that's a valid record. Now what I'm going to do is I need these columns to show up. So the parameter value, I'm going to negate the parameter value. Negating the parameter value will cause these columns to show up. So some people do like a and 1 equals 0, you know, and 1 equals 2. Some people do that. I like to just, if it's an integer, make it a negative number. If it's a string, I change it to the word null. So this is an integer. I'm going to change the 2 to a negative 2. So when I change it to a negative 2, what happens to my page? You guys see my page? I get these numbers that show up. I get a 7, a 2, a 3, a 4. These are the columns that echo back data. Now this is important, right? Because I needed this 9 placeholders. So if we look up a union select statement, we'll see that a union select statement is required come on, catch up. A union select statement is required to have the same number of fields in the result set, right? So a union statement allows you to join one select statement with another select statement. What we're trying to do is take the web app developer's SQL statement and join it to the attacker's SQL statement. So we need to have the same number of result set columns to do this. That's why we use the order by trick to figure it out. Now some people just count it out, right? They'll say union all select 1, union all select 1, comma 2, union all select 1, comma 2, comma 3, all the way out until they figure it out. That's another way that you can do it. Either way is wrong, you know, it's just different ways to do it. If you're going to do it where you just keep incrementing the number, I would recommend that you not use numbers. I'd recommend that you use the word null, N-U-L-L. We'll cover that later, though. Okay. So if we look here, column number 7 shows up. So up here in number 7, right here, 7 shows up. So column number 7. Let's change that to the word user. So change that to user. And if you guys see what I did, changing that like this made that the select user statement. And let's say we have number 3, so it's going to be this guy, right? So I'm going to change 3 to at version. Enter. So you see here was column 3, here was column 7, here was column 7, gave me that. Here's a 3, gave me that. This makes sense, guys? Okay. Now, the first type of SQL injection that we did is called error-based SQL injection. This is called union-based SQL injection, by generating a union statement. Now, the reason I'm showing you the union-based is because you're going to find that the error-based is getting harder to find. You know, you're just not seeing them out there like you were years ago. You know, back in the good old days, you know, in the heyday of web hacking, I would call it. Now, you really don't find so much of that stuff. You know, what you end up finding is a lot of union, and you find way more of something else called blind SQL injection. You find a ton of that stuff now. Error-based and union-based, they're on the decline. And login bypasses, we don't find very many of those like we used to. Okay, so if you guys are in Pastebin, I'd like you guys to do the rest of these. So Pastebin number, let's see, from line 24 all the way down to 47. Let's go ahead and let's do those. Okay, and if anybody can get it, paste the hash, paste the admin hash, the admin password hash, paste that in the question box. We'll see if anybody can get it. Oh, you want the text file? Sure, here you go, bud. There you go. Sweet, someone's got the hash. Awesome. Awesome. I'd love to see if anybody can crack it. Anybody? Anybody, I'll give you 10 minutes. If you can crack it in 10 minutes, I'll give you your next class for free. Okay, it is 7:09 p.m. Eastern. You can crack it before 7:19 p.m. Eastern Time. Next class is yours for free. Free. Come on, let's do this. Let the hacking begin. Okay, unbelievably good guess, but that is not correct. I had to try. Good guess, by the way. Good guess. All right. So while you guys are trying to crack that, I want to cover one more type of SQL injection, and that's blind SQL injection. So with blind SQL injection, let's say you're in a situation where you go to a web page and you insert your tick and you don't get an error message. So you insert your tick, you don't get an error message, or when you insert your tick, you're automatically redirected to a home page. That's a good little Band-Aid that some people will put on a website, right? So you're looking at that and you're saying to yourself, what can I do? So what you can try to do is you can say semicolon, wait for delay, space, single quote, 00 colon, 00 colon, 10, single quote, dash, dash. So if anybody looks at that, wait for delay. Okay? So what's going on here, guys? Can anybody tell me? What am I telling it to do? Good. Sleep for 10 seconds. Good. Wait 10 seconds. Good job, Zach. Good job, Satoshi. Good job. So you're trying to tell this, hey, wait 10 seconds. So if you go right here, I hit enter. If you guys look in the top left corner of my screen, you'll see that that's spinning, right? It's waiting. And then after 10 seconds, the page appears. So we've actually, by doing that, just proven SQL injection is possible. Because what you can do now is you can start to ask them questions, right? So let's say we do something like this. You're going to say if, what's going on here, guys? If the what? Anybody? There you go. Check the length of the user. Good job, Pete. Okay. So if the length of the user is 1 character, if the database username is 1 character, wait 10 seconds. I hit enter, the page comes back right away. So it's not 1 character. So if the length of the username is 2 characters, wait 10 seconds. It came back right away. So now I'll say if the length of the database username is 3 seconds, and you see it's spinning, it's waiting. So the length of the username is 3 characters long, D, B, O. Okay? So now, let's say I take a look here. Let's say I grab this syntax down here. Okay. So can anybody see what I'm doing? If ASCII lower substring of the username. So ASCII lowercase, I don't want the whole user, I just want part of the user string. So the username is a string, I don't want the whole string, I just want part of it. It's substring. User, I only want the first character, and the length of the substring is 1 character. So basically what you're asking is the first letter of the username a 97? And if it is, wait for 10 seconds. So if we go over here and we look, a 97 is the letter A. So you're trying to say, hey, is the first letter of the username an A? And it came back right away, so it's not. So I'm going to change it to a B, 98. Okay, it came back right away. It's not 98. I'm going to change it to a C, 99. It came back right away. It's not a C. I'm going to change it to a 100, and it's waiting. So the first letter of the username, which is 3 characters long, is a D as in David. We go over here and we look at it. 100 is a D. So now that we know the first letter is a D, you would now ask for the second. So you would change this to be a 2, and you start right back at 97 again. 97 is an A, it comes back right away. 98 is a B. Okay, it's waiting. So the second character is a B. D, D, O. This is called blind SQL injection. And it's horrible, horrible. No one likes to do this by hand. So we use automated tools to do blind SQL injection for us. So tools like SQLMap are going to use each of these methods that I talked about. So SQLMap is a great tool, one of my favorites. Actually, I probably shouldn't say one of my favorites. To be honest, it's probably my favorite SQL injection tool. Yeah, Hatosh, you're right. SQL injection takes a long time to manually find out column names and all that kind of stuff, right? But let's say, for example, if I just crack open my Linux command prompt and start making this thing find this stuff for me, you'll see that I just did a -B, and he came up with the banner. Let's go with --DBS. Boom, there's all the database names. Remember, lookup, master, model. These are all the ones we found by hand, aren't they? Okay, dash tables, right? Let's see. Let me make sure I get that syntax right. -D, lookup, -- tables. So we'll go like that. So -D from the book app database, we want to get all of the tables. And then, boom, there's our tables. See? Book master, sys diagrams, beautiful. Now, if we want to get our columns, right? If we want to get any of that kind of stuff, right? And then my favorite, right? If you want to dump the data in any columns or tables, just put --dump at the end. And we've now hit our 10 minutes. And we don't have anyone who's cracked that hash just yet. SQLMap will handle that hash for us. So we'll get that list. You guys can see that. I don't know how well you can see that. So right here, it says, hey, I got all the system users. Do you want to run a dictionary attack against it? I just said, yeah. And then I just choose option 1. Right? And then let me just hit enter. And now you see that he is going hog wild on this bad boy. Boom, got it. So got the hash, crack that sucker, password is database. You check crackstation.com. Okay, how do you use SQLMap with a param in the middle? Okay, SQLMap by default is going to test every parameter. So let's say, for example, so --DBS, right? And then right here you had an ampersand, user equals Joe, right? And ampersand session equals active, right? So for each set of parameter names, what Zach's question is what if I just wanted to test this, right? But what will happen is SQLMap is going to automatically test all parameters and prompt you, right? So when you run it, I know this isn't a valid URL, but SQLMap would prompt you, okay, testing this parameter. Now, do you want to test the next one? You just hit Y for yeah, and he'll jump and he'll test each parameter individually. What's really interesting is something called tone proxy. So with tone proxy, there we go. So with tone proxy, what people do is you chain you chain SQLMap and Burp Suite together. So as you browse the website by hand, the URL is automatically cast to SQLMap with the syntax that you wanted to run. Okay, so later on in the month, we'll cover that. Okay, that answer your question okay, Zach? Okay. Yeah, it kind of sucks in that even if you want to test one specific parameter, you can, but I'm telling you, I usually just let it test all parameters. I do believe there is a way that you can force it to test a specific parameter. Let me look that up real quick. SQLMap. Yeah, I mean, I've seen like when you have to do stuff like that for a post request, but I don't know for a GET request how you would do that. Let's take a look. Features, dependencies, usage. Cookie, user agent, offsite, talk to, tour, sync URL. Yeah, but I mean, we shouldn't have to go that crazy where we have to write a burp filter for it. Hold on. There's got to be a way. Let's see. Prefix, CPR, regex, fingerprint, enumeration, root. Okay, read file. Son of a gun. You might be right, Zach. I don't know if it. Might have to make that a feature request, huh? Yeah, man. I think you're going to have to make that a feature request. That's trace file. Okay. Okay, second order SQL injection, union calls, technique, textual content, tamper, no cache, no connection, threads, skip URL encoding, drop set cookie, son of a gun, you are right, Zach, man. We'll have to put this in as a feature request. Let's do it today. I'll do it. If you want, you can do it. But I mean, if you want, I'll write it as a feature request. Why the heck not? Yeah. Damn. Huh. Yeah, that is funny. Jeez, that is funny. You figured that it would do that, huh? Target, direct connection to the database, target URL, parse targets or burp or website, request from a file, Google Docs, INI file, HTTP data. See, check this out. You can define the separator between parameters, but you can't specify that you want, let's say, the third parameter name, parameter value pair only. That's pretty, user agent header, host header. You can specify additional headers. And you can do everything but that, huh? Man. Oh, well, sorry about that. Yeah, let's put in a feature request. Oh, no, check this out. Check this out. By default, SQLMap tests all get parameters and poster parameters. When the value of -- level is greater than 2, it also tests the cookie header values. When the value is greater than 3, okay, it is, however, possible to manually specify a comma-separated list of parameters that you provide to it. For instance, test for a get parameter ID and for HTTP user agent only -p. Wow, and then you've got this URI injection point. Oh, it can do it. Right, so the injection is within the URI itself. SQLMap is not performing automatic testing against it unless manually pointed to. Oh, that is pimp. Oh, that is pimp. Wow. That is pimp. I didn't know it could do that. That's pretty cool because, like, parameter name SQL injection, I always did by hand. So, like, let's see. So, let's see. Let's go not so secure parameter name SQL injection. So Sid from Not So Secure, he's got a good blog post on parameter name SQL injection, and so does PortSwigger too, by the way. Oh, man. Man, is it gone? Where was that page? So you used to have a page on parameter name SQL injection, right? Injection in the parameter name. Let's see if there's a cache version of the page. Yeah, see, here you go. So here you can see, you know, question mark parameter name equals parameter value. Normally you'd inject here, right? But you see that he's injecting here. So he's actually using brackets to insert his injection here. And this is freaking wild, right? So that now means that you can make SQLMap do that, because I always did this by hand. I didn't even know you can make SQLMap do this. Not just specifying which set of parameters that you want to test, but now you can now do parameter name injection and second order SQL injection. That's some pimp stuff. That's some pimp stuff. I didn't know that. Yeah, this would be really good for like CMSs and stuff like that. You know, the plug-in hell that all CMSs are, right? Yeah, very cool. Very cool. Yeah, man, I guess we all learned something today. Well, that's pretty cool. Yeah, that's definitely cool. Definitely cool. Hey, thanks for pointing that out, Zach. Shoot, man, that's pretty cool. All right, guys, well, listen, it's 7:30, so it's about that time. I say let's button this sucker up, hammer some nails in this coffin, and I'll kick you guys out a document. I'm getting ready to jump on another plane, so it'll be a few hours before I land. I think I got like a 7-hour flight. So I'll kick you guys out a document that'll walk you through this stuff and a bunch of other stuff. So just don't expect it tonight, probably expect it tomorrow morning. And, you know, let's jump in the lab and let's have some fun. Let's, you know, get in there. If you have other tools that you want to run against the websites, go for it. You know, maybe you've got like WebInspect or Burp Suite or, you know, Acumetics or NetSpark or something like that, and you want to try those things, you go for it. You know, you really have to just drive websites. Like, you don't learn a website by like watching a webinar. You know what I mean? So take this case bin and do everything in this case bin. You know, try to get through all of that before our next class. But also, when I kick out that document, try to get through all that stuff in the document that I'm going to kick out as well. So remember, this case bin is only going to be up for 1 day, so you want to grab it now. Right, I only put it up for 1 day, so it won't be up for very long. So grab it now and start playing around in the network. See if you can get this stuff working, okay? All right, so before I bounce, any questions for me? Any last questions? Speak now or forever hold your peace. Well, I guess till our next class. Sweet. All right, guys, let's bounce. Didn't you have greater 1 case bin? Didn't I have like a newer case bin, you mean? Is that what you mean, Matt? Or just that one dot today? Oh. Yeah, well, the one earlier, yeah, you're right, Zach. The one earlier didn't have the SQLMap syntax. That's why I made the second one. So they're the same. I just added the SQLMap syntax to the second one. So you're going to get a Word doc that walks you through all of this stuff with screenshots. But I really want you to just try this. I'll kick out that Word doc by tomorrow. And then let's get in there. Let's kick some butt. And let's try some other stuff. Okay? Definitely another interesting thing that you guys can try is Metasploit has an SQL injection module. You might want to consider trying to run that against the box as well. Okay? All right, be gentle on my box because I'm going to be in the air. I won't be able to reboot it for you for the next couple hours. So don't blow the thing up because I won't be able to help until I land, okay? All right, guys, I'll catch up with everybody on our next class. Today is Wednesday. Our next class is Monday. All right, see everybody Monday.